The resistor. What does resistor do? Resistor is the component which opposes the flow of charges or limits the flow of current in a circuit. This is the type of resistors. Here we can see different types of resistor according to their functionalities. These are the commonly used resistor around the world, and they have their unique features and part to play in the circuit. Now, let us see what is the colors on the resistor means. Colors on the resistor say their values. Since we can't put the wide range of values on a small device resistor, so what we do is we put colors on them so that we can differentiate what values they represent. This is capacitor. What does the capacitor do? Capacitor is a component which stores charges in electrical field. So the capacity of a capacitor to store the charges is capacitance. These are the type of capacitors. See, the capacitors can be differentiated in many ways: variable, polar, non-polar, and they have their unique features to play in their circuit. Now, let's see the internal diagram of the capacitor. The internal diagram of the capacitor is differentiated with two plates, metallic plates, and a dielectric medium in between. Dielectric medium is an insulator which will be polarized by applying an electric field, and this is the symbol of capacitor. This is an inductor. Inductor is a component that stores charges in the form of electric field. And now we can see the types of inductor. Here we can find an interesting thing is that a transformer is also an inductor. Yes, the transformer which you see outside your house blasting all the time. And here we can see a wire wound in a circle, that is a non-contact charger. Now let us see how an inductor is constructed. Inductor is constructed by taking a wire and winding it across a core material, and this winding makes an inductor unique and which is mainly responsible for production of magnetic field. And when you apply a current across the inductor, a magnetic field is generated. As you know, these are the magnetic field lines, which lines passes from south pole to the north pole whenever a current is applied through the terminals of the inductor. Resistor. The unit of resistor is ohms, and this is the symbol of the resistor. Here we have constructed a circuit. The circuit consists of a battery of 5 volts, a switch, an LED, an ammeter which is also known as a current meter, and a resistor of 1K. Let us understand the general working of the resistor by connecting it to the LED. As you can see here, the LED is glowing and the resistor value is 1K. Let's do a magic. What happens if I change the value of resistor? Let us try. I'll decrease the value of resistor. The LED is growing brighter, brighter, brighter. I'll increase the value of the resistor. Can you see the difference? This is what happens. It goes dim, dim, dim when I increase the value of the resistor. So, this is the simple general working of the resistor which opposes the flow of current. Let us check directly in the ammeter. The same process. Decreasing the value of resistor, that in turn increases the value in the ammeter, that is current increases. Increasing the value of the resistor, that in turn decreases the value in the current. Now let us go in the theoretical. Ohm's law. Ohm's law is said to be the important law in the entire branch of electronics. So Ohm's law states that current flowing through a conductor is directly proportional to its potential difference across its end. That means current flowing through the conductor. You can see the dotted lines, right? These are the currents flowing through the conductor. Is directly proportional to its potential difference. Potential difference means the voltage. So That means I is directly proportional to the R, and by changing the proportionality we get V is equals to I into R, where V is the voltage, I is the current, and R is the resistance. Now let's implement this. So ready for the magic? Let us try to find out V, and now we'll forget this, the value is 5 volts, and let's try to find out this value. So to find out this value we need I and R. Let us grab the value from the circuit. I is 5 milliamps, that is from here, and R is 1 kilo ohms resistance value. Now let's substitute the value in the equation. So we get V is equals to 1 into 10 raised to 3, that is kilo, and 5 into 10 raised to minus 3, that is milli. So we get answer as 5 volts. Now let us compare the answer. Oh, it's same. So the law holds. So we can find I, which is by cross multiplying, that is I is equals to V by R. Even we can find the R. R is equals to V by I. Hence this law is one of the milestones of electronics. So hope you understood. Next, let's go for capacitor. Capacitor, as it says, capacitor, capacity. You know the word capacity, right? Capacity means something which holds some store or holds stores something. So that's what capacity in general terms. So capacitor is a component which stores energy in form of electric field, and this is the symbol of capacitor, and this is the unit of capacitor, that is farad. Now let us see the circuit. The circuit consists of a battery, a switch, and resistor. A resistor is used for safety purpose. Most of the time resistor will be used to safeguard the circuit from any short circuit or like higher damages. And this is the capacitor, and this is an LED. Now let's on the switch and see what will happen. So when I switch on the circuit, LED is glowing. This is normal, right? What will happen if I switch off the switch? Even now LED is glowing. How is this? This is because of the capacitor. Capacitor actually charges. It's like a battery which charges when you apply the voltage, and it'll discharge when the voltage is removed, and it slowly fades away. As you can see that the red light in the LED is slowly dimming. So this is what happens in the capacitor, a general working of the capacitor. Now let's understand capacitor. How much can a charge be stored in a capacitor? Because it's a storing device, right? A component, right? So it has to store the charges. How much charge can be stored? We can see that by an equation. Q is equals to C into V, and Q is the charge, C is the capacitance, and V is the input voltage. So C, capacitance. Capacitance means the capacity of which, how much capacity can a capacitor hold a charge. That is the meaning of capacitance. And now let's see. From the equation we'll grab C and we'll grab V, voltage. That is 5. And here we'll consider, I've considered here 100. So 100 into 100 uh, into 10 raised to minus 6 into 5, that is 5 into 100, that is 500 into 10 raised to minus 6, that is micro. So charges 500 micro coulombs. This much charge can be stored by this small capacitor. And now you can see here the light has almost gone. Again I'll switch it on, again I'll switch it off, it charged again. I hope you get it. Next we go for inductor. Inductor and capacitors are like a brother and sister. They're like both opposites, but they are like they do the same function. So the same thing happens here. Inductor also stores the charge, energy, but it stores in the magnetic field. but capacitor used to store in the electric field. And inductor, unit of inductor is Henry, and its symbol, this is its symbol. And let's see the circuit. The circuit. The circuit consists of a battery, ammeter, LED, and an inductor. And there are many type of inductor as you saw, and there are two major way of finding an inductance. That is, there are two different inductance. That is self-inductance and a mutual inductance. Self-inductance, as the name says, self. That means only one thing is there, like yourself. Same way, self means one inductor. The mutual inductance means there are two of them, right? So you will have two inductors facing opposite. That is known as mutual inductance, and the mutual inductance mainly plays part in the transformer. As you know, the transformer, right? That works under the principle of mutual inductance. Now we'll study about the self inductance. Here what happens is, whenever you on the circuit, slowly current increases drastic way, like it's increasing continuously. This is what happens when you're connecting an inductor. The current keeps on increasing. And let's see what happens. The general formula, like general way to find a voltage, a formula to find the voltage is V is equals to L into di by dt. Here why are we using di by dt? That is differentiation, is because we don't have a constant current here. Current keeps on varying with respect to time. So we have to find, here we can see V is the voltage, L is the inductance, and di by dt is rate of change of current with respect to time. So here we, what if the current is a constant? What if this value, or we make it a constant? Then di by dt will become 0. Then the entire voltage will become 0. This is what happens. And as you can see in the graph, it is a linear straight line here. So this is what happens in the inductor. Now let's go to the serial and parallel resistors. Serial and parallel resistors. The resistors connection given to the resistor in a particular way is series and parallel. Series, as you can know, series means it comes one after the other. As can say, connection of a resistor one after the other. Like you are holding another person's hand, you are like one after the other. That is series. As you can see here, 1K, like we have in the circuit we have two resistors that is of different values, and a voltage source and a current ammeter to measure the current. And here this entire circuit, it looks big, right? So we can't make a big circuit, but we need the particular value. So what we'll do, we'll make this big circuit in the small circuit. So how will we do that? That calculations we are going to see now. That is, this two resistance we can convert into one resistor. How? That is using this formula. In the series connection, resistance R equivalent. R equivalent is this resistor, which is equals to R1 plus R2. That is R1 plus R2. That is 1K plus 2.2K makes 3.2K. You know it, right? The basic addition of two values. The same thing happens here. And the current here, the current remains same throughout the circuit. The value remains same throughout the circuit. So there's no adding up of current, but the voltage varies at every point of resistor. As you can see, the voltage is different here. The voltage is different here. So the voltage, what happens here is equivalent voltage. That means the voltage which we are getting in the equivalent circuit is this V1 plus V2. That is 1.563 plus 3.438, which gives 5 volts. This is what happens. This is the connection of series resistor. Now let's go for parallel resistor. Parallel means, for an example, there are two people, and you are holding your one hand, left hand. You are holding the right hand of the person, and the left hand, in your left hand you are holding is In your left you are holding his right hand, in your right hand you are holding his left hand. Just imagine that way. So that is known as parallel. That means you are facing each other, holding your hands. That is like parallelly. Both the hands are touching both the hands. Like that is what happens here in the resistor parallel connection. That means connecting a terminal at the same point. You have a same point on both the terminals. So here, as you can see that we have two resistors R1, R2, a voltage source, and a milliammeter ammeters. That is the current meters to measure the current. See, you have the same contact and the same contact at the top also. This is what says parallel connection. And here, this big circuit can be converted into a small circuit by how we are going to do the necessary calculations. The necessary calculations is the equivalent resistor, finding the equivalent resistor, current, and voltage. That is, the equation of the resistor is 1 by R equivalent is equals to 1 by R equivalent is equals to 1 by R1 plus 1 by R2, which gives 6 1 1 by 1k plus 1 by 2.2k, that comes 1 by 687 ohms, which will be like when you cross multiply you get this value R equivalent. Then in this circuit the current varies but voltage remains constant, directly different from the series circuit, where in series circuit you had current remains constant but voltage varies. In this, current uh, uh, varies but voltage remains constant. Here I'll add, here current varies and voltage remains constant. Remains constant. So as you can see here, the voltage which we applied, it is 5 volts, 5 volts, right? Now across first resistor, the value of current is 5 milliamps. Across second resistor, the value of current is 2.27 milliamps. Hmm. So the equivalent current, what should be the equivalent current? That is I1 plus I2. You get the equivalent current. Now uh, let us check the value of resistor. Let us check the value of resistor from the circuit. I1 is 5. The value of the current in the circuit, that is the I1 is 5 and I2 is 2.273. So what happens when you add up 5, 6, 7, that is 7, 2, 7, 3, 2, 7, you have to get 3, but this is approximate because the answer for R1 parallel R2, that is 687.5 ohms. This is the parallel connection of the circuit. So today we saw resistance, capacitor, inductor, serial and parallel connection of the resistance.